Thanks for being here. My name is Steve Gaynor. I have a consulting company called Pivoth Corp, and what I do is help product manufacturers internally with mostly product management stuff. So new product introduction in the Rainscreen market, growth strategies, technical compliance, certification stuff. That's what I do for my day job. I also am part of the Rainscreen Association in North America. I'm the vice chair and a board member there, and that's what we're going to be talking on behalf today. The Rainscreen. Oh, it's going in and out. Okay. Shannon, you got to help me out here.
Yeah, you hear it. All right, you're on.
Hello, hello, hello. Okay. I'll just start screaming. I'm okay with that. Okay. All right, so the Rainscreen Association is an entirely volunteer organization. We'll talk about it at the end of the presentation a bit, but I'll give you a pitch to get involved. And then I'm also an advisor for a company called AceLab, and they're connecting product manufacturers with specifiers on a platform designed for architects. If you're interested in any of those three, feel free to come and talk about them afterwards. Again, the Rainscreen Association, this is their website. That's a QR code you'll see later. I'll give you an opportunity to get there after the presentation to the membership page. So today we're going to talk about cladding and Rainscreen. And really what we're going to talk about is the source, I guess, of the misnomer of people calling, looking at a cladding system and saying, that's Rainscreen, or maybe looking at the wrong cladding system and saying that's Rainscreen. And we're going to sort of parse out between what's cladding, what's Rainscreen, and how they work together. So we're going to start out with water management of walls. So just basic wall science, the types of walls, types of cladding, and then cladding integrated into Rainscreens, and then I'll give you my pitch on the Rainscreen Association. So to start with, it starts with water, right? So walls are about protecting the inhabitants from the exterior, and there's a bunch of different ways that water gets into walls. And if you have either designed your water to take, or your wall to take water, or maybe you've designed your wall not to take water and water gets inside, then you have to know how that water is going to get out of your wall system, right? So where does water come from? So first you get precipitation. Everybody, that's the obvious one. Condensation, right? So you see on here, you see condensation on windows. We've all seen that before. But within a wall system, there's a lot of parts that could gather condensation depending on your cycle of the day and where you are in the country, your climate in general. And that's another source for liquid water. And then vapor drive. You see, I have a guy vaping there. It's not really the cause of vapor drive, but you have water vapor coming through your wall system at different times of the year, depending on where you're living, either coming out of your wall system or into your wall system. And you should be learning how to control that when you're designing and installing your wall system, or else that vapor, as it changes planes, leaves liquid water in certain parts of your wall system. And what happens when you don't control the water in your wall system? You get problems, right? So you might get leaks, obviously, and that can cause damage in a number of different ways. You see on that top picture, maybe that's freeze-thaw damage. I really don't know what it is, but you've seen freeze-thaw damage on things like stone and brick and other products. And then you see the efflorescence on the brick on the lower left-hand side. That's when water goes into the wall system. Maybe it doesn't have its route out and has to come back out through the brick. It carries with it the salts in the brick and deposits that on the face before it evaporates, right? And then hopefully not mold, right? Those are your biological concerns when you're starting to mismanage water. So when it comes to liquid water, what does it take to get a leak? This is the golden triangle. This is what I've lived by for 20 years. If you have liquid water, which is moisture, an opening, and a force all in the same place, you're going to get a leak. That's as simple as that, right? So if you can divorce any of those three, you avoid leaks. Great. Easy enough. The forces, forgive me this showing up a little differently on the screen here, but the forces that create leaks, right, are numerous actually. So it's not just wind driving rain into your wall system, right? So that's the kinetic force. But you could get surface tension forces where the surface tension of the water on whatever it's on carries it someplace you didn't intend for it to go. So it's sticking to maybe a panel system that was damaged or misfabricated or something like that and going into a place it shouldn't go. Gravity, obviously, water's going to find the lowest potential energy, and wherever that is, whether it's your basement or a gutter, that's where it's going to go. Capillary action, we're all familiar with how water can travel not only down but up through small spaces and the surface tension of water. And then pressure differentials. Once you get that water to bridge a gap, pressure differentials on either side is going to move that water one way or the other. So when you're designing walls, there are traditionally 3 major categories that you're thinking in terms of water management strategies in a wall. So traditionally, and especially still in other parts of the world, you're seeing a lot of mass walls. And so mass walls are concrete, stone, brick walls, full width walls. And those we're calling storage walls because they can take up to 500 times more water than a stud wall system before they create a problem with leaks, right? So traditionally, if you're in a temperate area like Europe, right, and you're building with a stone wall system, you're getting pretty quick wetting and drying cycles, and as long as those balance out, you're not getting water coming into your inhabitants area. Then you have the exclusion strategy, and this is what we've done in cladding since the 50s and before. This is where you're saying, okay, let's put all of our water barrier or water control layer on the outside of our building. So this is like sealed metal panels, this is stucco, EIFS. You might have even sealed concrete, something like that. And so you have to have a perfect barrier there to have perfect performance. And then finally, what we're here mostly to talk about today are these drainage walls, right? And so that's where Rainscreen fits in, but there's a much larger category called drainage walls. And that's where you start putting a multi-layered wall system in. You're saying, okay, water can get through the first layer. We're going to take that load off of our water control layer, which we're tucking behind that first layer. And that way we avoid leaks. Even if we have some water problems that we didn't anticipate on the front side, we're taking the load off that water control layer, which is underneath it. So, we used to have even when I started, mostly just building paper and something in front of it. Obviously, that's not working anymore. We want to make each part of the wall system, that high performance, the highest performance that we can in terms of a functional wall system. So you're seeing these different water management products out there now, right? So you see the membrane products. You see the membrane products happening at multiple layers too, right? So this is against your sheathing, you're getting maybe an air barrier and a water barrier, and then you might just have a water barrier that's not an air barrier in front of that, depending on how you're designing your wall system. And then you also have these dimple sheets to control your water and direct your water once it gets back into the wall system. So we're thinking about different layers now, right? So we go from that mass wall system to that exclusion where you could have one layer, you could have multiple layers, but you're really keeping water on the outside, to the different layers of the wall system. And so what we have here is an example of a drained wall system and the different layers in that. So we're here to talk about exterior cladding, right? This is, then behind that, you're creating an exterior cavity with an attachment system or some other way that you're furring that out. Then you have the exterior insulation underneath that, usually on top of your water-resistant barrier. And depending on where you are in the country, you may or may not be using exterior insulation still, but I guarantee you it's coming for you soon. So let's talk about that first layer, right? Cladding. What makes cladding cladding? So Merriam-Webster says cladding is something that covers or overlays, which pretty good definition. I mean, it sort of covers what we're talking about, but it's not good enough for us, right? So the Rainscreen Association did some research, went to about 10 or 20 different sources that talked about cladding the exterior, and came up with a definition for cladding that covers what we're talking about today. And that's a non-load-bearing wall element, inclusive of any coating or finish, serving as the outer layer, which is unprotected from exterior environmental conditions, right? And that really covers most of what we call cladding in wall systems today. You see that non-load-bearing wall element is in blue. That means that we have a definition for that too, because we started this definition saying we wanted to define cladding. Non-load-bearing is an essential part of these types of components, because as you get into code and compliance, the difference between load-bearing and non-load-bearing means a lot of difference in terms of performance that you probably don't need on a cladding system, right? So what we found was that non-load-bearing is actually not a term that's been well defined. It's not in the code. You have something that's called load-bearing in the code, but you don't have non-load-bearing. So we felt we had to define that as the Rainscreen Association, and we came up with this definition. So it's a material or system that transfers load to the structure, does not contribute to the overall structural performance of the wall, and resists its own weight as well as loads imposed by surface-mounted accessories that are allowed by design. That's non-load-bearing. I think it's probably the first definition you've seen of non-load-bearing. I mean, whether or not you geek out on this stuff, I'm guessing I might be one of the few people here, but it's one of the only definitions out there for non-load-bearing, and it gives us an important distinction in those areas for compliance. If you were at the presentation yesterday from Andrew Ashton, he was representing RAiNA also. He was the chair of the definitions committee, and they took months to come up with this with building scientists and representatives from AIA and the rest of the industry. So again, cladding is a non-load-bearing wall element inclusive of any coating or finish, serving as the outer layer, which is unprotected from exterior environmental conditions. Now we're going to revisit those wall systems with that in mind, right? So you have a brick wall system, right? Which is, if you have a multi-width brick wall system, you're probably using that as your load-bearing wall, right? Right off the bat, that doesn't really qualify as cladding. It is your outer surface of your wall system, but it needs to do different things than cladding needs to do. So that's obviously your protective layer, but not considered cladding. You might have brick that is considered cladding, and we'll get into that after this. Actually, if you have a multi-layered, right, a thin brick veneer on a concrete wall system, you still have that mass wall system, but now you have a brick cladding. That cladding doesn't necessarily need to have a standoff or ventilation behind it. You have that cladding component, non-load bearing, it's there for a different purpose. For your barrier walls, now we're all familiar with sealed metal systems, right? So sealed panel systems that are my typical reference for barrier walls. You have your panel layer, and then you have wet seals in the joints. And in that situation, you have cladding on most of these walls, right? You have a backup wall, and then you have cladding. Again, it's not necessarily a Rainscreen. It doesn't meet what we're going to talk about later on, but it's cladding. And it has its own, probably very similar requirements to cladding that is part of Rainscreen. And then you have your drainage walls. And cladding in drainage walls starts to take on a bit of a different form. You're often using very similar materials in very similar ways, but then you get to introduce new materials because you have this drainage space that gives that outer wall some balance, right? Where you couldn't use some materials in the same way you'd use a metal panel. Now you can start to use different materials. Now, the types of cladding that are out there, I've just listed some up here, but you see a lot of metal, right? And we're going to go through just about all of these in the next 15 minutes or so. But what's important here is that this cladding, cladding isn't specific to a material. We can make just about any material into a cladding material. And it can be used in different ways, but you have to pay attention to the material properties. So we're going to start with metal. Yay, MetalCon! ACM, MCM, I'm assuming this is what most of you guys are dealing with. This is a metal skin product that has some sort of polymer core, usually FR, and we fabricate it into cassettes. I've seen metal, ACM used the same way that that other, let's say, more rigid claddings are used, where you don't fabricate it into cassettes, but for the most part, you're doing a cassette system, fit into each other, and either dry or wet joints. From an aesthetic standpoint, this is what you're getting with ACM. Obviously, we're seeing a lot more. I mean, if you've been to AIA in the past couple of years, you see incredible geometric designs happening with ACM systems. I don't know how often you guys are doing those in your own shop, but they're pretty impressive for showpieces. Then you get into single skin metal, right? And so, with ACM, you have that polymer core, right? So you don't necessarily have a non-combustible product, and then you have compliance considerations that you have to consider on top of that. So, with single skin metal, that's just whatever type of metal you're dealing with, maybe painted or sealed or whatever, but is either being fabricated into cassettes or just panels that are attached, maybe even in exposed fastening systems. The benefit of single skin is that not only often are you rolling it, it's fairly easy to fabricate, but it's non-combustible, right? So where I live in New York City, they just passed some very restrictive building code language that limits combustible products pretty severely. Single skin products are one of the few products that fit nicely into the new code. Then you get into other metals, right? So you have zinc, copper. I've heard of titanium. I've never seen a titanium product, but heard of titanium. And you're pretty much treating those similar to single skin, except they might have their own needs in terms of design and fabrication. Sticking with metal, you have your insulated metal products, right? And these are insulation that's skinned over on both sides by either steel or aluminum, and that insulation is most typically foam, but can also be mineral wool. What's interesting about insulated metal panels is that they're intended to be insulating, right? So with the other metal panels, you can seal them, you might not seal them. You're typically sealing the insulated metal panels to get that insulation value. However, I've seen a couple projects where they're using one of the other characteristics of these panels in a ventilated facade, which is an interesting choice from my perspective, but is happening out there, right? One of those benefits is the long spans you can get out of insulated metal panels, right? You can put up 20-foot panels and keep them pretty rigid with insulated metal panels. How many of you deal with insulated metal panels? Okay, good. Now we're getting out of the metal side of stuff. So if you want to leave, feel free. I won't be offended. You start to get into things like traditional masonry. So you have those brick systems. You have brick as a traditional load-bearing wall system, and then you have brick as a cladding material. And we're talking about brick as a cladding material. And this is a single width brick. Traditionally, you're putting on a lintel and stacking it up. But these days, we're doing all sorts of different things with brick, right? You've even seen thin brick systems that go up like a panel. So they're put on a metal piece and then put up like a panel on a wall system. But one of the benefits of brick, again, it's non-combustible. So you get that benefit again in New York. Brick is one of those few products that we can easily fit into the new code. Stone cladding is the same thing. We're seeing tremendous changes in stone cladding. Now, one of the products that I helped introduce into the market bordered the masonry side of the business. When I was doing that, the masons were essentially focused on stone and brick and those sort of products. They wouldn't touch anything else. They operated different than panel installers. They were familiar with the traditional way of stacking stone up and attaching it to the wall that way. Not exactly like brick, but similar mindset to a brick wall system. Today, you're seeing all sorts of ways that stone's going up. You could put stone up in exactly the same way you're putting metal up. You just use some different fasteners, and you have to do a little bit of different, site testing. But we're seeing all sorts of ways that natural stone is being used, very similar to any other cladding material, and again, non-combustible. Then you have your ceramics and porcelains, which are exploding onto the scene. Traditionally, you'd have, if you were going to build with ceramics, you'd have very small ceramic pieces, and they would have plunge cuts in the side, and you would stack them up. You might put them on a traditional Rainscreen system where it's standing off the wall, but you would still stack them up on top of each other. Now we're seeing 5-foot by 10-foot porcelain panels in thin gauges, highly engineered, highly designed to go up like you would other panel systems. The difference here is most of the products that if you have a CNC that you're cutting metal on, you might be able to cut something like the two. We're going to talk about fiber cement, HPL on those. As you get into these masonry products and porcelain, you're talking about a totally different setup and wet cutting. It's essentially the companies that bridge those gaps are few and far between, but that's growing as these segments grow. Porcelain aesthetics, you're getting very flat panels, again, larger panels. Typically, you're getting natural tones and things like that, but the technology with porcelain is increasing, and you can even get custom printed images on porcelain panels. Then you have terracotta. How many of you actually install, other or deal with other products other than metal on wall systems? Okay, a few of you. Great. Then you have terracotta, and terracotta is obviously thousands of years old, and we're still making it. I'm not going to say in the same way, but in similar ways. It's a traditional building material that you see on the oldest buildings in New York City and around the country, and now we're putting them in highly engineered Rainscreen systems. But often you're seeing terracotta in standard heights, extruded. It's a wet process, sort of fits into the ceramic family, but has different qualities than ceramic. You see with terracotta, you get a lot of flexibility, but you're often, also often limited to whatever that extrusion die is. From an aesthetic standpoint, you can see, you probably know it. You see those standard heights. The architects are typically happy to design with those, not having to think about sort of where all the joints lay. Those are controlled for them. And then you have fiber cement. Fiber cement is a cementitious product, and we're going to get into a few of these. But fiber cement is water, sand, cement, fiber, and air. And those fibers can be organic fibers, cellulose fibers, or they can be glass fibers or whatever. But they help hold the material together. And then they're either air cured or autoclave cured. And fiber cement, similar to your porcelain products, you're typically getting those sort of natural colors. Forgive me, natural colors, but you can get a lot of texture in fiber cement that you might not be able to get with other products. They're also going up in those large size panels. They're custom made. A lot of your metal equipment can actually cut fiber cement panels, and we're starting to see some of the traditional metal fabricators switch over to or add fiber cement to their products. GFRC is another cementitious product, similar makeup, a little bit different, using glass fibers, typically non-combustible. Fiber cement can be combustible or non-combustible depending on the product coming from the manufacturer. GFRC is typically non-combustible. It's also usually put up in thicker thicker, more customized designs. Ultra high performance concrete. Has everyone heard of ultra high performance concrete? Yes? No? Okay. So these are again in the cement family. They might have fibers in them like the other products, but they're often a denser product, and they're often thicker, and they're put up in again, large panel formats. From an installation standpoint, most of the installers won't really know the difference between installing these three different products, except for the weight of them as they're installing it. Then you have precast, and precast is an interesting one because precast has been used as that mass wall system in the past, but we're also seeing precast go into cladding now, right? So you're also seeing precast go on top of a wall system. Sometimes that's for schedule and installation, things like that, but we're seeing precast as a cladding in this industry more and more. Then you have high pressure laminates. Who's dealt with high pressure laminates? Yes, good, great. High pressure laminates are a combination of wood fiber and phenolic resin, and they press those at high heat and high pressure, and they come up with this monolithic panel that is very flexible, very, you can put any designs onto it, into it. They're putting a paint layer on top of it. But you have to deal with the fact that it's wood and phenolic resin, and you have to make sure that you're complying with fire codes. So you have a lot of flexibility there, pretty easy to handle, pretty easy to fabricate, and then you have your compliance issues on top of it. Again, you're doing large formats, customized cuts, similar to a metal panel layout. You have, architect is drawing the lines wherever they want to draw them, and you're cutting it to those specifications, designing it. Then you have engineered stone. Engineered stone is, natural stone, calcium carbonate, a resin to bind it all together, usually some sort of fibers to reinforce it, and typically in a fairly, maybe ½ inch to an inch thick, put up similar to other systems. Engineered stone is one of those products that has to be balanced, and so you're typically putting it up in a ventilated facade. Now, a lot of these products can be sealed. They can be put up, depending on what the product needs are. So, for example, HPL has that wood in it, right? So it needs to be balanced on both sides because that wood's going to absorb humidity just like any other wood. So it's not going to be sealed to a wall system, but a lot of these products can be, maybe even tiled onto a wall system or put into a Rainscreen system. So which one of these products is a Rainscreen? Obviously, I think I've given you that answer already and enough information to say that none of these are Rainscreens, right? They are all products that go into Rainscreens, right? Does anybody have a question on that? Because we need to address that right now, if that's, okay. So how do we get to a Rainscreen, right? So we're going to go back to the wall system. As we think about wall systems, we have, those mass walls, those exclusion systems, and those drainage systems. We're going to break those into what you need a perfect barrier for and an imperfect and the imperfect barriers. And I know using the word imperfect is not great marketing, but it's it's sort of a good way to think about this. So with those sealed systems, whether you're putting a sealant on concrete or sealing metal, you want to make sure that you're creating a perfect barrier. It has to perform perfectly, and you're maintaining it so that those joints don't dry out or no cracks in the sealant, so that when water gets into your wall system and it has no way out, it's not causing problems. Imperfect barrier, you're allowing water to travel behind that cladding, and that can be a number of different assemblies. So again, with that mindset of what is Rainscreen, we're laying out sort of a progression of wall systems going from face sealed all the way to a pressure moderated rain screen. And you see this blue line in the middle is where we define this is a rain screen, this is not a rain screen, right? They have, and this doesn't mean it's not better and worse. That's not what we're talking about here. We're talking about for different projects has different needs. You're designing maybe a face sealed system on certain projects because that's the need on that project. Then you go to concealed barrier and drained wall systems. So these systems just before the blue line do have a drainage plane in them, but they're not going to have enough of a plane to allow for ventilation. All right, we're way good. So they're not going to have enough of a plane behind the cladding to allow for ventilation, just drainage. As you go beyond that blue line, you get into rain screen. That's where you get the ventilation and the drainage behind your cladding system to allow for the rain screen principle to work. And so you start with a drained and vented wall, and then you move to a drained and ventilated wall, and then you move to a more sophisticated, a little more complicated pressure moderated wall or pressure equalized wall. Any questions? All right, good. So, Rainscreen Association defined Rainscreen as, obviously, was their first task as the Rainscreen Association. There were a lot of different interpretations of Rainscreen, including just how you spell Rainscreen, whether it's one word or two. But essentially, it came down to an assembly that's applied to an exterior wall, which consists of, at minimum, an outer layer, an inner layer, and a cavity between them sufficient for the passive removal of liquid water and water vapor, right? So it's a pretty wide definition. It allows you one layer, a cavity, another layer, and that cavity has to be able to do two things. That's it. Then you have a rain screen, great. Everything else is up to the design of your wall system, right? What does your building need beyond that? So let's give a visual there. You have, number one is your cladding, your outer layer. Number three is that cavity, the cavity created by the outer layer and the inner layer. Number two is that inner layer, and then you have your ventilation and or your removal of water vapor and liquid water. So, as we start to talk about the components in a rain screen, and we talked about all those cladding materials, it means that almost any cladding and any backup wall separated by a cavity that is drained and vented or ventilated qualifies as a rain screen. Congratulations, you have a rain screen. However, it's not a product, right? So none of these materials in the wall system are rain screens, right? They all contribute to a rain screen when they work together. And for the residential side, and the Rainscreen Association has a strong residential committee, you have products that create that space for the ventilation and drainage, those dimple mats and so on, and give you those rain screen principles, but they have to be in, again, a rain screen assembly. So, again, I'm boring you with this definition, but it's important to note that there's different parts of this definition. Worked on for 6 months at the Rainscreen Association, so I'm proud of every word in this freaking definition. But at minimum is a key part of this rain screen definition, right? Because you could have those two layers and that cavity and have a rain screen, but that rain screen might not be acceptable for your wall system. And if you just have those two layers and a cavity, it's probably not acceptable. You need to have more thought in that design. So there's other things that make up a rain screen in terms of designing high-performance rain screens. So you do have your cladding attachment substructure support. You have your exterior insulation. You might have not only a water-resistant barrier, but an air barrier in there, depending on where you are and where you want that air control to be. And then your vapor diffusion. So that might be your air barrier. It might be a different place in your wall system. Again, based on the design of your wall. Every component in there has a role, and they all need to work together, right? So they have an individual role, and they also all need to work together. Here's some, it's a little bit hard to see, but here's some section details of different rain screens. They all have the same thing, whether, depending, they might have different claddings on them, they have different attachment supports, Some you don't even see insulation on, but they all are rain screens. So, what's a rain screen cladding? I'm a little bit ashamed to say the Rainscreens Association spent a couple meetings on this before they were like, oh yeah, it's a cladding that's using a rain screen. That's the definition of a rain screen cladding. But it's important that it's water shedding, right? So you want to make sure that you're reducing the load on that water control layer, which is typically deeper in your wall system. And so that rain screen cladding needs to have some water shedding capabilities. So beyond water shedding, it needs to be put up in an assembly that allows for liquid water removal and water vapor removal. So as you talk about integrating claddings into Rainscreen, there's also a lot of other considerations. You have the design of that cladding. So for a metal system, you might be putting together a cassette system where you don't have any visibility to whatever's behind the cladding, right? So that it interlocks, it may be wet or dry, it doesn't matter, but it interlocks and you're not seeing behind that cladding. For a lot of other materials, you're putting an open joint in there. So you might see the insulation behind it, the water resistant barrier behind it. You might have to mitigate that for a few reasons. One's aesthetic, right? Our architects don't like to see through that joint and see whatever's behind it. Another reason might be the UV durability of whatever's behind it, right? So the openness of joints, the joint design, again, we get to fire considerations, right? This is a big thing. I've been involved in what's going on in New York City for 18 months, and that's all about the fire consideration of your wall assembly. Depending on what you're using in there, not just the cladding, but the components behind it, right? So if you have a cavity that's different than what's tested, right? That cavity might be larger or smaller than what's tested. That means that we have to think about what that fire performance is. Does it qualify for whatever was tested before? Again, also cavity, we've hit it over and over again. Drainage, ventilation, right? Difference between venting and ventilation. So a lot of metal systems out there, especially pressure equalized systems, right? They'll use a technique, and this is not indicative of a metal detail, right? This is a typical, like a rigid cladding material. But a lot of metal systems and systems that don't need to be fully balanced can use a vented technique where you actually put that vent space in the bottom of the panel, close off the other three sides, allow for water that gets in there to get out, allow for some exchange of airflow, but not full airflow in terms of ventilation. To have ventilation, you need to make sure at the top and bottom of wherever you're putting your horizontal flashing in there is fully open, and that your cavity is fully open. So if you have horizontal supports, you need to make sure that they're either perforated or that you have something behind or in front of that horizontal support to make sure that you have a continuous vertical cavity for ventilation. So to design that cavity, and also for a lot of other design considerations like your thermal performance and sometimes your fire performance considerations, you see a lot of cladding attachment systems out there. By last count, there's about 25 companies in the US that just offer cladding attachment systems. And they all have their own little niche. Traditionally, when we're looking for high performance systems, we were going with aluminum claddings, like a T&L type system that you see up here, where you have a wall clip and then some sort of rail on top of that. And you have a lot of iterations of that. I would say out of those 25 companies, you have like 15 to 20 that are primarily selling that. But then you have other materials. You're seeing materials like stainless steel, which has very high thermal value, it's non-combustible, and you're seeing companies come out with those sort of options. You're seeing FRP options, where they're non-metal options for your thermal performance, but then you get into your compliance issues for things like fire and making sure that you still meet the code. There's a lot of people that are also involved in Rainscreen design, right? So you have designer considerations are all of the technical things we just talked about, and the aesthetics of the wall system, right? Because they want to make sure that they're designing an aesthetically pleasing wall, something that's going to have their name on it, right? And so things that we don't think about, and sometimes on our side of the industry are kind of a pain. Designers are thinking about how can we use this material differently to make something that's unique, but still maintain all of those technical performance requirements that we want. Skip over that. For those considerations in terms of technical performance, this gets down to often gets down to what the manufacturer is saying, but is also backed up by a lot of testing, right? And so this is where you get into your certifications and you're testing for different materials. For the most part, most of these tests are material tests, right? There's only a couple of system tests out there for Rainscreens, but most of the tests are about you're going to use this material at this point, test it for its material properties. You're going to use this material behind it, test that for its material properties. Who knows if they work together well? But the material properties, pass the smell test. The Rainscreen Association is sort of focusing on that. That idea is that we need to start integrating this thought process. AMA or FGIA has two standards that do incorporate the whole system. That's AMA 508 and 509, and those are tests that evaluate the performance of the Rainscreen in terms of water. And then we have NFPA 285 and S134, which evaluate a whole system in terms of fire, right? So it's not just a component of the system. And then as a contractor install, you also have a lot of considerations, because you could have a designer that is designing a system behind your Rainscreen that's not appropriate for the material that you're putting in cladding, right? So if you have, let's say you have very long metal spans without a break, and you have something like fiber cement or porcelain or something that's not going to have the same thermal expansion contraction as that metal, you're setting yourself up for major problems down the road, because that metal is going to want to move, the material in front of it's not going to want to move. It could easily be solved through strategic breaks in that metal in different areas, but if you don't realize that the different parts of your wall system have to work together, you're doing things like this, and you're coming up with cracked corners and so on. Same thing with installation. You have to do a lot of things in the field that aren't on the drawings, and so you have to know, as I'm making a decision, does this work with this? How do these things go together? So all of that brings me to my last pitch for the Rainscreen Association. It's, the chairperson for the Rainscreen Association put this slide together. To me, this is a particularly ugly sandwich, but it shows, all of these parts of this sandwich have to work together to make a delicious sandwich. It's the same thing with the Rainscreen. So this is why we need the Rainscreen Association. We have all of these components, all of these stakeholders working on Rainscreen together, but they're often not working together, right? And at the center of all of this is where we have successfully installed high-performance, multifunctional Rainscreen assemblies. So naturally, after 10 years of hitting our head against the wall trying to organize, in 2020, we formed the Rainscreen Association of North America, or in North America. And that's where we are bringing together the manufacturers, the designers, the engineers, contractors, et cetera, and coming up with standards together rather than separately like we've been doing for decades. We have about 100 member companies in the association that are working literally every week on different things. Each of the member companies has representatives on different committees. I'll show you that in a second. But the idea is to integrate the expertise from around the industry, have building science-based performance criteria, right? We haven't created any standards yet. We're only a couple years old. But we've been working towards that from day one. And then focus on sustainable, long-lasting building enclosures. Again, this idea about Rainscreens is about bringing components together. It's about bringing things together that were working separately. When we started the organization, there was this idea that we don't want to reinvent the wheel here. We don't want to start working on metal panel standards. MCA has been doing an awesome job of that, right, for decades. And what we want to do is we want to take whatever's been done in the industry and incorporate that into this integrated mindset, right? Just want to see where we are, okay? 12 o'clock. So we have working relationships with the Air Barrier Association, with MCA, with FGIA, with AIA. We share information, they share information back. We want to make sure that if there's expertise in an area, as we're talking about air barriers and water barriers, we're taking people from the Air Barrier Association and incorporating them in the conversation so that we can use what they're putting out, and they can incorporate what we're putting together. And this is all done through 7 working committees. This is the structure of the organization. On the bottom, you see the 7 working committees. So our 100-member companies can have representatives on whatever committees they want that are voting members or just observers. And they're participating in conversations about the terms that we just went over. We're making code changes that help start laying the path for integrating these different components into an assembly, having that mindset in the code, which is not in the code right now. Education and training, right? Obviously training the industry about these things. And then I talked a little bit about our residential committee before. What they're doing is they're sort of taking this whole, all the work that's being done on mostly, I have to say, bias on the commercial side, and making sure that the residential industry for Rainscreens has some focus, right? So they take, resources from the performance committee, from the codes. We got Rainscreen into the IBC and the IRC last year, so in 2024 you'll see that. And they're making sure that that residential is being focused on, because residential is a huge part of Rainscreen. And then we have our newly formed Diversity, Equity, Inclusion Committee, and that's both internally focused and externally focused. And in my opinion, I think a sorely needed view in our industry. The RAiNA Board of Directors, you see my beautiful face in the middle on the bottom there, but we have people from the engineering world, we have people from the architectural world, we have an installer on there, and then we have some manufacturers, and then I'm a consultant, right? So we have a fairly good representation of voices from stakeholders around the industry, but we're probably looking to expand and get more diverse voices in the next few years. And then the idea is we're a working organization. We're not a marketing organization. We want to make changes that structurally in our industry in America and Canada and Mexico. And so we're striving to be an accredited standard development organization by 2030, so that we can create standards that can go into codes and other standards. And then this third point is actually pretty important. So the Rainscreen Association, you may have noticed, is our biggest chunk is manufacturers. But the idea is by 2030, we want the voices that are leading this, like the designers, the contractors, those people that are on the ground in terms of applying Rainscreen knowledge, to be the major voice within RAiNA, to be leading RAiNA, because that's the only way that you get the work that we're putting out to actually have some benefit out there. And so there's a major drive to get those voices in there. And I'm proud to say this year, manufacturers actually became less than half of our membership. I'm hopeful that continues to grow. A few points here. I think we've talked about most of it. About the code, about the glossary, if anyone's attended yesterday. We have some CEU presentations. We have these presentations. But we also have newsletters and the website. So please feel free to go on the website. This QR code is for the application. Looks like everyone's got the phone out. Good, great. No, I'm joking. But please go to raina.org and see what we're about. So that does it for my presentation today. Feel free to reach out to either Rainscreen Association or myself. I'll be here or over in the booth for the next couple hours. Thank you.